discuss the concept of reversible and irreversible cell. Now suppose I have two cells, that is cell C1 and C2. Suppose this is cell C1, positive, negative, and here there is another cell C2. And these two cells are joined parallel. Now suppose somehow I am able to regulate the EMF of the cell C2. I can increase or decrease the EMF of cell. But here the EMF of cell C1 is kept constant. Suppose the EMF of the cell C1 is denoted as E1, or it is called driving EMF, and EMF of cell number C2 is an opposing EMF. Now when these two cells are joined in a parallel combination, in this case there will be a competition between the two cells for flowing the current in the circuit. That is why we have used the two words, that is the driving EMF and the opposing EMF. Now when there are three conditions when E1 becomes equal to E2. Suppose the EMF of both the cells are equal, then no current flow through the circuit. That means no cell reaction occurs at the respective electrodes. All cell reaction gets stopped. There is neither oxidation nor reduction at the electrodes. So there will not be a flow of electron into the circuit. Now here, if you see the case number 2, that if E1 is greater than E2. Now here, one thing should keep into the mind, that the cell which having higher EMF will take command of that particular circuit, and that cell will be responsible for flowing the current in the circuit. Now here E1 is greater than E2, that means here this cell is responsible for flowing the current into the circuit, because this cell have now taken the command of this outer circuit so that the electrons flow in the circuit. Now normally, suppose there is a cell reaction for C1, A plus B plus gives A plus B. And it's a cell reaction. Suppose this simple redox reaction which occurred in this cell. Now in third case, if opposing EMF E2 is greater than E1. Now what happened here? Now this cell take command over the circuit, and it is now responsible to flow the current into the circuit. So what happened here? Since the E2 is greater than E1, it tend to reverse the cell reaction. That means here at this case, this cell reaction is now reversed, like A plus B gives you B plus A. Now the cell in which the same reaction is reversed due to slightly greater opposing EMF, that particular cell is known as reversible cell. So every reversible cell have to fulfill all these three conditions. That means if E1 is equal to E2, then no current flows through the circuit. If E1 is greater than E2, then it flows the current through the circuit, but E1 have the natural spontaneous chemical reaction, forward reaction would occur. But if the opposing EMF E2 becomes equal to is greater than the E1, then the cell reaction, forward cell reaction now get reversed. That is A plus B gives you B plus A. Now the very nice example for the reversible cell is the Daniell cell. Now suppose C1 is the Daniell cell. Now here in Daniell cell is a reversible cell. That means here one can reverse the spontaneous cell reaction by just increasing the opposing EMF. So in case of Daniell cell, the normal redox reaction is this, that is Zn solid plus Cu aqueous gives you Zn2 plus Cu solid. Now this is the cell reaction of Daniell cell. Now when the cell is a Daniell cell, then when the EMF of Daniell cell becomes equal to EMF of other cell, okay, then no cell reaction occurs. There is neither oxidation nor reduction. But when E1 is greater than E2, then this cell is now responsible for flowing the current into the circuit, and that is why the cell reaction occurs in a forward direction. Now in third case, if the opposing EMF, that is E2, is greater than E1, then what happens? This cell now take command, and this cell will try to flow the electron into the circuit, and in doing so what happens? This cell forward cell reaction get reversed. Okay. That is why the Daniell cell is called a reversible cell. Now what is the irreversible cell? The irreversible cell which do not allow to reverse the cell reaction, whether you increase EMF or you decrease EMF. Okay. So that irreversible cell do not follow these three conditions. Okay. So there are two types of cell, reversible and irreversible cell. Hello friends, let us consider a topic that is the measurement of cell EMF. Now the EMF of cell can be determined by a method called as compensation method. Now we have seen that when the two cells are joined in parallel combination, and when the EMF of the both of the cell becomes equal, no current will flow into the circuit. Now this method is based on this compensation method. Now for this purpose what we require a battery source, number one. Number two, we require standard cell. Number three, we require a cell for which we have to determine the cell EMF. Now the arrangement of the circuit or the potentiometer, we will see that suppose there is a battery source. Now here the EMF of this battery is very higher as compared to the standard cell as well as the cell taken into the consideration. Now let's see, the positive end of this cell is linked with two cells, that is cell number 1, say C1, and a standard cell, say S. And here the battery, suppose C2. Now here the positive end of the battery source is joined with both of the cells, and the negative end of cell C1 and standard cell is joined through to the jockey through a key. Now there is a potentiometer. Potentiometer simply consists of a wire, what is called nichrome wire, which having uniform cross-sectional area. Say the wire is connected here, wire AB is there. So one end of this wire is connected to the positive end of this battery. So here positive, negative, and the negative end of the both of the batteries are joined to the jockey, and jockey is joined through a galvanometer. Suppose there is a galvanometer. Now galvanometer, when the current flows through the circuit, galvanometer show the deflection. Now this galvanometer is joined through a sliding key, what is called a jockey. Now this is the arrangement, and this negative end is joined here to the B, like this. Now this is the arrangement in the potentiometer. Now when we close the key of C1, then C1 will include into the circuit. When we close the key of S2, then S will enter into the circuit. And let us put a key here. Then C1 now becomes in opposed with the C2. That means here C1 is now included into the circuit. So when we slide this jockey, the deflection, there will be a deflection, and this galvanometer show a deflection. But when we slide this jockey at a point, say Y, where the galvanometer show no deflection. There is no deflection. What does it mean? It means that the EMF of the cell C2 becomes equal to EMF of the cell C1. That is why there is no flow of current occur in the circuit. Now here, now then this key is open and the key of standard cell is closed now. Now the standard cell is taken into the circuit, and then again this jockey is slided over this nichrome wire and is slided at this point. Suppose the galvanometer show the no deflection, that is no current is flowing through the circuit. Now here this point is known as null point. That means when no current is flown through the circuit, there is no deflection in the galvanometer, that particular point is called null point. Now for cell C1, the null point will be at Y, and the for standard cell the null point is at Y prime. Now here, if suppose E1 is the EMF of cell C1, E2 is the EMF of cell S, that is the standard cell. That means here why we call it as a standard cell? Because its EMF is known to us. That means the cell whose EMF is known previously, that is called a standard cell. Now, the EMF of cell C1 is now proportional to the length AY. And the EMF of cell standard cell, that is E2, is proportional to the length A prime. So we can write here EMF of cell C1 is proportional to the length AY, and EMF of standard cell is again proportional to AY prime. Now why we write these relations here? Because the battery source is the same. That means here both of these cells are compared with the same cell, that is C2. That is why we are able to write this relation. Now if we solve this, then we get EMF of cell C1 or E1, say E1, E upon E2 will be equal to, if we divide this, then length AY upon length AY prime. Now since the EMF of the standard cell is known, we are able to calculate or determine the EMF of unknown cell, unknown EMF, that is E1, of the length AY upon length AY prime into E2. So this length can be determined by this, the length of wire. In the potentiometer, you know, there is a scale below the nichrome wire, and with the help of that scale you can determine the length AY and A prime. So we know the length AY prime, and we also know the EMF of standard cell. Then by doing this calculation you can calculate the EMF of cell. So it's a very simple method that we use, and the arrangement is called as a potentiometer method.